The second stage of photosynthesis, the Calvin cycle by Filan and Tango. In summary, 3-RUBP plus 3 carbon dioxide is equal to 6 PGA. Creates G3P, which is the most important product as it can make glucose. Does not need sunlight, unlike the first stage of photosynthesis. Carbon fixation, inorganic carbon to an organic molecule. You need 3 carbon dioxide and 3-RUBP to make 6 PGA. The 3 carbon dioxide and 3-RUBP are catalyzed by rubisco. Rubisco is an enzyme that catalyzes the reaction of carbon dioxide and RUBP. CO2 is from the atmosphere. Reduction adds energy by adding electrons. 6 PGA becomes 6 BPG by borrowing 6 phosphate groups from ATP, so the ATP becomes ADP. PGA is phosphoglyceric acid and BPG is biphosphoglycerate. 6 BPG becomes 6 G3P by getting 6 hydrogen molecules from NADPH. 5 of the G3P molecules are going to be used for the next stage of the Calvin cycle, which is regeneration, and 1 G3P is stored for future use. BPG is biphosphoglycerate and G3P is glyceraldehyde 3-phosphate. It is the most important product of the Calvin cycle. 3. Regeneration. Some G3P molecules are used to make glucose. The 5G3P becomes 3-RUBP by borrowing 3 phosphate groups from ATP, so ATP becomes ADP. G3P is glyceraldehyde 3-phosphate and RUBP is ribulose biphosphate. In the first stage, carbon fixation, 3CO2 and 3-RUBP are catalyzed by the enzyme rubisco to create 6 PGA. In stage of reduction, the 6 PGA becomes 6 BPG or biphosphoglyceric acid by borrowing 6 phosphate groups from ATP, which then becomes ADP. The 6 BPG then becomes 6 G3P by borrowing 6 hydrogen molecules from NADPH. The 6 G3P are split up into 2 groups, one with 5 G3P and one with 1 G3P. The 5 G3P are going to be used in the next stage of the Calvin cycle, which is regeneration, and the 1 G3P will be used for future use. In regeneration, the 5G3P borrows 3 phosphate groups from ATP and recycles itself as RUBP, thus restarting the cycle again.